generally from the trend that we are seeing, I would go along with again the prediction that experts, right, have been making, that look, in the coming, let's say, of the order of 10 years, we would see some very, very significant capabilities that you could say, yes, these are truly systems that are on par with human capabilities on a very broad range of problems, on a very broad range of tasks. At the same time, and again, I don't see that as a negative. As a researcher, I find it exciting that we continue to face a lot of challenges, right? So we've seen that challenge of hallucination in these models, for instance, right? That these are ultimately probabilistic models, so they may make up what seem like very convincing facts. I do see that we will continue to have at least certain very open problems, right, for the researchers to still address, even as we reach these kinds of AGI capabilities.
Hi, friends, and welcome back to Leading with Data, a podcast where we talk to leaders in AI and bring out their learnings and perspectives for you. In this episode, I talked to Dr. Manish Gupta. Manish currently serves as the Director of Research at Google, leading teams in India, Australia, and the US. Prior to Google, Manish had spent more than 20 years working with companies like IBM, Xerox, and Goldman Sachs. And more recently, he built his own startup, VideoKen. During his time with IBM, he also led the team developing system software for the Blue Gene supercomputer. IBM was later awarded a National Medal of Technology and Innovation for Blue Gene by the US President Barack Obama in 2009. Manish is also a fellow of ACM and the Indian National Academy of Engineering and a recipient of a Distinguished Alumnus Award from IIT Delhi. During this podcast, we talk about his journey in AI and ML, recent developments in generative AI, and why he values going after 10x problems instead of incremental challenges. He'll be at DataHack Summit in a few days, and I hope to see you all there. Now to the podcast.
Thanks, Kunal, for having me.
Great. So, Manish, I would want to start from how were your early days in this field? How did you get into the field, and then your journey till this point where you're leading this research team at Google?
Sure. So I started my journey as a researcher earlier at IBM Research in the US.
Mhm.
And at that time, I used to work on very different areas. I used to work on compilers and high performance computing, so system software for supercomputers. So it's when I moved back to India. Um, at that time, I was with IBM Research,
Mhm.
and I saw a lot of my colleagues again really applying. In those days, AI was a bad word. We used to call things like data analytics or machine learning for various problems, both kind of problems derived by the services business as well as kind of real world problems facing customers of the company. So that really got me excited about this area because you could see now the impact of the work, the technical work that you were doing. You could see the impact in many cases firsthand on the users around you and on everyday people. So and over the years, again, as I kind of took on different roles, I saw again, in some sense, the percentage of the work that was in some sense driven by AI and machine learning just going up and up, to the point that when kind of Google approached me, they talked about this as basically heading the Google AI lab.
Mhm.
The entire focus of the research team that we uh, built uh, was around AI. And in fact, most recently, and it was recently announced that our team has now joined the Google DeepMind
Yeah.
organization, which has its mission uh, pretty much is to build AI responsibly to benefit humanity. So there's a very strong element of focus on AI in the entire mission of the organization that again I'm now part of.
Yeah. And personally, when you reflect on this. You mentioned that AI was also a bad term when you kind of started in the domain. So at a macro level, how have you seen this things evolve? And were there any specific, let's say, milestones or periods which you felt were kind of very different acceleration or very different feel to it from your perspective?
Yeah, absolutely. So, I mean, already what was becoming clear in the, let's say, the early 2000s, and even prior to that, was the whole field was being dominated of AI, was being dominated by machine learning, where you really have models that learn from the data. Uh, and again, thanks to continuing improvements in compute power and more greater availability of data in digital form, you continue to have, again, some very impressive advances in the field of machine learning. But I would say one inflection point came again with the arrival, or maybe we should say reincarnation, of artificial neural networks as deep learning. And we all know about the famous that image classification, those MNIST benchmarks,
Correct.
the image classification, where deep learning made that comeback and showed a dramatic improvement in error rates from using artificial neural networks. And that, I would say, was a turning point, because very soon after that, on so many different problems like speech recognition, like machine translation, uh, so a very wide variety of problems. So it's very kind of now surprising in hindsight that for such a broad range of problems, essentially like the same technique of artificial neural networks, it started working so well, and started providing the state of the art way of solving those problems, uh, in some sense overtaking, right, a lot of the more conventional ML approaches that, again, many people in the community had developed. I don't know, we probably lost
I
communication for a while.
think that, yeah,
Uh, that over the decades, right? So, for instance, in speech recognition, there had been that community developing kind of language models, acoustic models,
yeah,
bringing them together to ultimately have these speech models. And that was overtaken by this end to end learning based approach, where you simply fed millions of labeled data examples, right? Audio and transcribed audio, and the deep learning system started doing better. And we saw, again, kind of that uh, pretty much trend apply to so many other broad areas. So, that I would say was the first kind of a phase of
mhm,
deep learning. And then came, of course, that famous uh, attention is all you need paper, the
yeah,
transformer architecture, and the era of foundation models that began arguably with this models like BERT, where instead of having to work with kind of data that needs to be labeled, they started with just with so much of openly available data on the web, and use self supervision this time, right? So where you masked out some data, so and you built a model to predict those missing words. So the beauty of the self supervision approach was that you didn't need to label any of this data. And and again, what was very remarkable about that series of advances is that, uh, while in the past, again, you had deep learning based methods providing the state of the art way of solving those problems, you, for every new problem, you had to build and train a new
yeah,
network from scratch.
yeah,
And what was remarkable about, again, these foundation models and the use, and that's the reason Stanford researchers coined this term foundation models, that as you build these models, they started providing a better foundation for solving so many different problems, because you started to see so many different, let's say, language, text analysis problems, all solved very well by a single model that you had built. In fact, a very vivid illustration of that came from the Google research team when they built the Palm model. They compared the performance of this Palm model on 58 different benchmarking tasks with the best known model, the state of the art model for each of those 58 tasks. And they compared the performance of Palm with those 58 on those 58 different tasks with the best known model. And while yes, on some tasks the custom trained model was doing better, on a vast majority of the tasks Palm based model was doing better and than the best previously whatever custom trained model. So that again started showing up in pretty much all of the scenarios, again in speech recognition, just starting with even unlabeled speech and then fine tuning the model with much less amount of labeled data, started giving you better performing, more robust models than those built using purely supervised approaches. Likewise, for image processing, I mean, our researchers found that for medical imaging, just starting with even unlabeled images, building models with good representations for those images, and then fine tuning them with labeled uh, images, again supervised learning on those labeled images, started giving you higher performing models. So that again uh, led to this, again I would say pretty like s- strong like move towards, again you were beginning to see those models with very broad capabilities. So at least the goal of AGI, artificial general intelligence, right, started to kind of appear,
Knowledge.
now reachable, as you started to have single models with very very broad and amazing set of capabilities.
A couple of follow-up questions to that. Right? So first, when you started, were you more of a symbolic AI researcher or this neural network-based research? And then how was your own perspective developed during this period?
Yeah, so as I said, I was neither. I was actually more of a compiler and
Okay.
systems programming
Okay.
researcher. But yes,
Hmm.
as I learned, uh, what I really picked up and what people in the teams that I was leading were primarily doing machine learning. So again, not really too much of symbolic
Hmm.
kind of analysis and so on. So pretty much machine learning, and I would say around like 2012 and later years, really deep learning very quickly got
Yeah.
established as the de facto kind of a leading method. So a lot of, again, teams that I was leading were essentially using artificial neural networks,
Okay.
and certainly at Google, I mean, uh, sometimes these terms were even used interchangeably,
Yeah.
because so much of, again, all of these capabilities were being driven by deep learning based methods.
Yeah. And second is when you looked at some of these foundation models coming out for the first time, what was your reaction? And then was this the same paper which you mentioned, the 58 specialized models versus one, or this was before that, after that? And then
Yeah,
how was your reaction to it?
yeah, so I mean we had seen some of that coming. For instance,
Hmm.
when I was doing my startup, um, we were doing again analysis of videos, and when Google released the BERT model
Yeah.
embeddings, we saw that
Mhm.
my own startup's kind of methods, we actually updated it using the BERT embeddings, and we saw a boost in the quality of our own models that my startup was building. So we could already see that broad kind of impact of many of these methods. And then I remember when I joined Google Research, and we were hosting an event for students, a research event with students from India, and Jeff Dean was giving that talk. He was supposed to come in person, but because of the pandemic, as you can imagine, all of those events were held virtually at that time. So I remember a student asking Jeff Dean that question, that what is it about current models that you find unsatisfying? And he gave that answer, that look, I mean, the fact that pretty much for every new task you have to train a new network from scratch, just sounds not very satisfying, because this is not how humans deal with new tasks, right? With new problems. Humans don't throw away all of their years of learning when solving a new problem. So there were already, again, efforts at Google Research, right, along that. So so certainly yes, they didn't come as a kind of a complete surprise to us, but
Mhm.
still the level to which these models could beat custom trained models, that was still very impressive.
Interesting. And so standing where we stand today, right? There are again, multiple streams which people project from here. But I would love to hear your views on what do you think about the scaling laws? Do you think that we can continue to feed more data and throw more compute and then continue to see some gains? And then, in your perspective, where is AGI on this roadmap?
Yeah, so these are great questions. So one is, yeah, I mean, I think uh, while we have seen again a lot of the traditional kind of uh, data available on the web already being utilized by these models, uh, I believe there's a lot more to the world than the kind of data, right, so far that these models have been trained on. Because one thing that I often think about is, I mean, how do scientists, right, make observations, make discoveries? They observe the real world, uh, and 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 I think I'm looking forward to the day, right, when also some of these models and so on, right, are also trained on real world observations, and are able to make sense of the real world data. uh, I mean, some of my teams have also been, and including some of my colleagues at Google DeepMind, Google Research, they've been also working on these models that understand the Earth, the planet, because we have been very interested in looking at problems in terms of agriculture and so on. So I think on one hand, I feel again there's a lot more variety of data uh, that I think is yet to be fully exploited in many of these models that we build. So that's one. Yeah, the other is, I think, yeah, we'll continue to see. Uh, so we've already seen that trend of started with large language models, and already these models are now becoming multimodal. So the Gemini models, and especially with this long context window that Google has recently demonstrated, have some, again, very amazing kind of multimodal capabilities. They're able to understand images, text together, as well as videos. So that's an area where I think we'll continue to see very significant advances in these, so that these models are going to be multimodal, um, in terms of their basic capabilities of understanding and generation. Um, I think we are going to see maybe greater convergence, because traditionally, again, a lot of the generative media algorithms, right, have tended to be kind of very different from some of these foundation models that have been used to um, build these chatbots and or understand things. So I think we are going to see greater convergence. And one of the areas that I'm very excited about is as we start to build these very very powerful agents, uh, based on these capabilities of these multimodal models that are able to interact with us. Uh, uh, Again, using all forms, right? Where they're able to take language input, and not just like typed input, speech as input. They're also able to observe us, observe, uh, in fact, even our emotions, observe how we are reacting to them, as well as observe kind of the environment around us. So you would have seen glimpses again in the work of several companies, including, like, again, DeepMind, Google. At IO, we showcased Project Astra,
Yeah,
right, which is again building one such agent, which is able to interact with the users
right.
using this rich kind of multimodal input output. So you're going to again continue to see those kind of advances. So I think already, as I mentioned earlier, now people are getting optimistic that, yeah, that many of these capabilities are extremely kind of broad and general. So you can see glimpses, you can see some glimpses of hope that yes, AGI seems to be coming. Of course, there are also a lot of open challenges. Uh, so that is my view, that we are going to continue on this path where, on one hand, we will have these AI models having some mind blowing capabilities in terms of being able to analyze not just uh, text, but also speech, videos, audio, and so on. So they will have those amazing capabilities. At the same time, they will also have very significant kind of, maybe you could say, weaknesses or areas in which there is still further work to be done, right, to strengthen those capabilities. So how do you make these models more robust when kind of the data that you encounter in the real world is very different from the data that you have been trained on? uh, Ensuring that these models are fair, they're not perpetuating biases, and in general, right? So are more robust, and likewise, to be able to scale these models, right, to again the entire humanity. So there's a lot to be done before we are able to make every human being on the planet, right, benefit from the use of these models. And that's a key theme, one of inclusive AI, that my team, certainly in India, has been working on.
Yeah. And if you have to put a timeline on AGI, and I know it could be, very different from what actually turns out to be, but what horizon would you put that on?
So again, I mean, look, there's a famous saying: it's hard to uh, prediction is hard, especially of
Yeah.
the future. But generally, from the trend that we are seeing, I mean, I would go along with, again, the prediction that, I mean, experts, right, have been making, that look, in the coming, let's say, of the order of 10 years,
Mhm.
we would see some very, very significant capabilities that you could say, uh, yes, these are truly systems that are on par with human capabilities on a very broad range of problems, on a very broad range of tasks. uh, at the same time, I mean, and again, I don't see that as a negative. As a researcher, I find it exciting that we continue to face a lot of challenges, right? So we've seen that challenge of hallucination
Yeah.
in these models, for instance, right? That uh, these are ultimately probabilistic models, so they may make up what seem like very convincing facts. Uh, so uh, I do see that we will continue to have at least certain very open problems, right, for the researchers to still address, even as we reach these kinds of AGI capabilities. Just like we say, no human is perfect, I don't think the AGI models will be perfect either. So there will still need to be lots of very interesting, challenging, and useful work to be done, in my view, for many decades. Um, I don't think we will kind of, in 10 years, we will say, oh, we have solved all of the major problems and now we are done. I think we are in it for a long time. I mean, there's a lot more exciting problems to work on.
Yeah. And one of the uh, key things that you mentioned, which is enabling AI for every human out there, specifically on that point, given the kind of advancements which are happening, the way models are getting released, uh, what are your thoughts on, let's say, potential risks or dangers on, some people getting access early to models, or having that disbalance between just because of the access to the models and intelligence?
Yeah, so what I would say is, Kunal, even before we talk about the access to the
Mhm.
models, the asymmetry,
Yeah,
there is already a very significant asymmetry in kind of, let's say, the capabilities that these models have for mainstream languages like English,
right.
and languages, let's say, that we speak
Yeah.
in India, right? That majority of people in India speak, like Hindi, Tamil, Bengali, and so
Yeah.
on. So there is already, we see a very significant difference, right, between the quality
Correct.
of these models' capabilities on a language like English with like a language like Hindi, and then further gap when it comes to other languages like, let's say, Tamil, Gujarati, Bengali, and so on. So and then when you get to really low resource, extremely low resource languages, there's an even bigger gap.
Yeah.
So I think first and foremost, there is that gap that first needs to be filled.
Mhm.
So there, yes, if you are a user, let's say you are, I often think about that laborer's daughter in Chhattisgarh or that farmer's son in Assam, right? That how do we democratize access to information for all of them, and bring them to the same level as you and I, people who are the privileged ones who understand English. And so we have information at our fingertips. How do we bring that same level of information, right, for people who don't
Yeah.
speak English, or who are speaking relatively low resource languages? So to me, that's like first and foremost, right, as a very big gap that I believe needs to be addressed. Of course, another big gap that we worry about a lot is, it's well known, right, that these large models are extremely computationally intensive.
Yeah.
Um, and today, I mean, theoretically, right, I mean, let's say, or hypothetically, if every human on the planet, right, wanted to make use of these large models, there
It
isn't
would
enough
be,
compute,
yeah.
right, in the world today to serve
Or even
every
energy
human
could
being on
be
the
a
planet.
big challenge.
The energy would go through the roof, the hardware needed, and so on. Even if you poured whatever trillions of dollars into it, there isn't enough hardware, right, today to run these workloads at that scale. So that's another uh, area of very active kind of work by my team. In fact, right here in Bangalore. So I think of those two as very very key, in some sense, barriers to the use of these large models to benefit users at large that need to be overcome. And then of course there are uh, issues in terms of that we need to also come up with thoughtful ways in which we then utilize these models to solve real world problems, especially problems that have previously not seen as much attention. So one example is area like agriculture, where again I have a team working on addressing those problems in a more scalable manner. So can you now analyze satellite uh, imagery, Earth observation data, and kind of uh, tackles and help tackle some of these problems at scale, right? By being able to identify field boundaries, being able to identify crops that are being grown, being able to estimate the yield, and being able to, again, identify sources of water body and other activities. So, can you, again, tackle those problems and then uh, work with other partners who are solving real world problems, right? For access to loans for farmers, access to insurance for farmers, or whatever subsidy programs for farmers, and so on. So I think, uh, and likewise in health, there's so much work to be done in learning. There's so much work to be done uh, putting some of these very impressive capabilities of these large models to good use to create these personalized learning solutions for every learner. So I think, again, there are opportunities to do some very very uh, amazing and impactful work in these areas.
Great. Thanks. Thanks for sharing that, Manish. Uh, Manish, during this period, right, when you have been at the helm of research and kind of leading several teams, there have been a few changes in the way research itself has evolved, right? So, for example, the role of academia versus, let's say, industrial research, which is happening, that's been a big shift. Uh, Also, the view about open sourcing the research versus keeping it proprietary. So, first, what do you think about some of these trends? And in the, let's say, next few years, how do you see this evolving?
Yeah, so I personally have been a very big proponent of stronger academia industry collaborations.
Mhm.
And at least in the years that I've been after coming back to India, I'm certainly delighted to see again the strides we have made
Mhm.
in terms of improving industry academia collaborations. Because if you go back, whatever, 15, 20 years, uh, I mean, sometimes people in academia were, in fact, very explicitly incentivized, right, to keep their work pure,
Right.
not be kind of polluted by kind of industry and those kind of motivations,
Mhm.
and really kind of be true to the theoretical, in some sense, underpinnings, and just uh, uh, in some sense not be driven too much, right, by what the industry wanted to do,
Right.
to today, where you do have again academia working on a lot of real world problems, uh, both collaborating with industry as well as like collaborating with startups as well as incubating new startups. So I think we have come a long way. There is still room to improve, but I am very encouraged by how far we have come. Yes, I mean, there is definitely kind of been that sense that uh, a lot of, I mean, if you look at a lot of the major advances in AI itself, right, many of them have come from the industry. If you look at, let's say, the
Attention.
transformer
Yeah.
work, and a lot of the action on kind of some of these large multimodal models, uh, that is happening in the industry. I personally think academia has still an extremely strong and very, very relevant role to play to a I mean, if you I earlier talked about how many of these large models, right, still have some glaring weaknesses. So there is so much work to be done, right, on how do you fundamentally tackle some
Mhm.
of these shortcomings of the current models. B, again, there is a lot of value in being able to come up with those kinds of capabilities, develop those capabilities, right, without just throwing very large volumes of data, large amounts of computation, which industry is certainly very good at. But how do you make sure, right, that you're able to achieve? I mean, if you can try to build even more powerful, superior models by utilizing much less data, much less computation, there I do feel that some of that frugality, that in some sense you are forced to adopt, that can actually be an advantage, because often, right, I mean, they say necessity is the mother of
Mother.
invention. I mean,
Yeah.
that pushes you towards directions where you truly come up with breakthroughs. So we do need ultimately better kind of uh, models with better scaling laws. um, I would love to see again uh, new architectures evolve that do better than transformers, and so on. And again, academia has a very significant role to play in helping come up with these kinds of breakthroughs.
Interesting. Interesting. And then, yeah. And on just double clicking on, large models versus small models, uh, how do you see that playing out? And then how would, let's say, the ecosystem look in a few years?
Yeah, so again, uh, my own team and I have a very, very specific view. So I don't know if you are aware of this work called Matryoshka representation learning and
Mhm.
Matryoshka transformers. In short, we call it matformers,
Right.
from my team, where what we have shown is that we can build even these large models in a very nested style,
Right.
so that smaller models are contained within those larger models. So once you train, let's say, a large model, embedded within that large model are like thousands of models of varying sizes, uh, which are as good, which are as effective as independently kind of trained model of that smaller size. So we are certainly excited about that direction, uh, as a way, as a real world solution to some of these problems. So allowing again these nested models, which we call Matryoshka models, Uh, and so we've already kind of deployed Matryoshka representation learning has been used in some of the vision embeddings and text embeddings from Google that get used in Google search by Google products like Lens, and which are also an offering from Google Cloud. Our Vertex API, Vertex AI has again some of those embeddings, which allow again our enterprise customers to, from the same kind of a model, use whatever size is suitable for their purposes. So at least that's our take on that
Interesting.
particular issue.
And what was the let's say if I were to measure the RAM required for inference from a model like this versus the equivalent large language model, what is the kind of savings we are
Yeah, so
gaining?
what we show is through this Matformer approach, we basically, let's say you've trained, let's say, an 8 billion parameter model.
Hmm.
Embedded inside that 8 billion parameter model is a 4 billion model, a 2 billion model, 1 billion parameter model, half a billion, and actually thousands of intermediate sizes as well.
Hmm.
So now, depending on the amount of, let's say, RAM you have, depending on the amount of
Interesting.
compute resources, either you have or that you want to utilize in a given environment, because
Interesting.
you may choose to serve a very large number of users. You may choose to kind of keep the overall compute resource, right, uh, uh, kind of limited,
Interesting.
bounded. So you can choose whatever design point, right, is appropriate for your requirement.
Wow. Interesting. Very interesting. Uh, wow. Yeah, that's actually very interesting in terms of how it can evolve and the future possibilities uh, it can transform into. Uh, Great. Uh, uh, Manish, just want to touch upon your journey, which you mentioned briefly before, but I would just again want to go deeper. So you were in research, and then you moved and started VideoKen as an entrepreneur. How was that experience? And then for a, let's say, young professional early in their career, uh, what would be your advice given that you've seen both sides of the spectrum?
Sure. So one advice that I give to everybody who joins my team is that it's very important for us to take a longer term view of
Hmm.
our career, of our life, of our career, and part of being ultimately, if we truly want to be successful in the long term, uh, I think it's very important for us to be able to take strategic risks. uh, I personally feel that often there's a, by default, there is often a tendency to go towards incrementalism,
Yeah.
that we often, like, when you have young researchers joining, often kind of the immediate kind of thought on their mind is, oh, let me pick a problem that I believe I can solve, that I believe I can solve very quickly, right, in the next 3 months or 6 months, which would, let's say, depending on what environment you're in, give me my next paper or give me my next whatever uh, impactful contribution to a product launch uh, in industrial setting, or both. uh, and while that is very natural, and while, yes, every kind of a, like, major breakthrough, again, it becomes much more useful as there is further incremental innovation. So nothing wrong with incremental innovation, but I think it's very important to be not just stuck only pursuing incremental innovation, because uh, in the long run, I feel it kind of makes you plateau out in terms of your overall impact, overall contributions. So I believe it's very important every once in a while to take those risks, solve really, really ambitious problems uh, that you may not be confident that you can solve, but if they were solved, would make a huge difference to the world. So that's a lens that I often ask again my team members to apply. If you were successful, what would happen? How would the world change? How would Google change? How would the users be benefit, right, from your work if you are successful? And if, let's say, as you ask a series of so what questions, if you find that, look, uh, you only change the world in a slightly, I mean, you make things slightly better for whatever, a few 100,000 users and so on, that's not good enough, right? So, I mean, you want to target problems that, if successful, right, would change the world in a very, very significant manner, would make life a lot better for, again, ideally billions of users. So, and so there, I think it's very important to pursue those kind of problems every once in a while, even if the risk of failure when you pursue those large ambitious problems is much higher, right, than the risk of pursuing those incremental sure shot to solve problems. Because uh, because even if, let's say, you fail miserably, uh, because it's a hard problem, I find the act of pursuing those ambitious problems itself pushes you to learn so much.
Yeah.
And if you learn from those failures, I believe those failures set the pave the way for big successes down the road. Because uh, there's so much of literature that as I've heard various like experts talk about what led to their success, invariably you find like a crucial ingredient to success was failures. That ability to that fearlessness, right, to pursue those really ambitious goals, uh, not being uh, fearful about failing, and then learning from those failures. So even in the worst case, kind of, you do benefit from those failures. That learning is very helpful. And and sometimes, even if you kind of don't succeed in your original at your original goal, the very act of pursuing something much more ambitious may drive you towards success, right, in a adjacent goal, which is still more impressive than maybe those incremental goals that you were pursuing. And again, if you are successful at the original goal, um, one of these successes, I think, gives you a lot more satisfaction, a lot more impact than like 10 incremental kind of accomplishments. So that's definitely an advice I give to
Sure.
um, everybody who works with me. And i'll I'll give that advice to every young, uh, whatever, every student, that yes, please do pursue some of these ambitious problems, right, as you go into the real world.
Very, very interesting. And thanks for sharing that framework. And assuming you're giving this advice to your own younger self, uh, and I ask you to pick maybe one or two problems or areas, what would those be? So areas of
Yeah,
research or
so I
areas
mean,
of problems.
yeah, so I mean, so definitely it was, again, this kind of a thinking that led me to also ultimately pursue a startup. And again, I mean, even though my startup wasn't entirely successful, I still think it was very worthwhile. I consider, even when I made that move to India, prior to that, kind of, I was work leading software effort, system software effort for a uh, supercomputing project called Blue Gene, which was almost like considered a foolhardy project because the goals were extremely ambitious. And again, when we managed to make that system work, and many years later we got a National Medal of Technology and Innovation from the then U.S. President Obama, for that work, it felt extremely satisfying. Uh, so I do feel I've benefited from, uh, like, at least being in a position where we are pursuing some of these very, very ambitious problems. And again, I've had my share of failures, uh, and I personally feel, again, even having lived through all of these, some of these successes and failures, I feel it's much better to have, again, lived through those multiple failures and a few successes than it would have been to just kind of go with some very, very like boring or predictable kind of successes.
Great, great. Thanks for sharing that. So, Manish, you are going to be a speaker at DataHack Summit as well. Uh, what is the theme of your session, and what can the audience expect from your session at DataHack?
Yeah, so the primary theme again, I'm planning to talk about again the this whole trend that we have seen in terms of the first phase of deep learning and then this new phase of foundation models and where it's taking us. So talk about some of that, including kind of how these models are being used to now in some sense uh, also revolutionize kind of some of the more creative aspects, right, of human endeavors, and then focus a lot more on this inclusive AI theme, which my team in India has been working on. How do we develop AI in a manner that brings benefits to everybody, every human on the planet, including the billions, right, who have not previously been touched by these AI methods? So that would be my primary theme, like including our work on language inclusivity, including our work on efficiency to make these models scale to very large number, to serve a very large number of users in a cost and energy effective, efficient manner. Um, and again, applying these models, right, to tackle problems like agriculture, public health, that had previously not received as much attention.
Great, great. Manish, towards the end of these podcasts, we ask our guest a few rapid fire questions, and the
Sure.
idea is to just know you better as a person. So, any books which had a great impact on you, or which you would want to recommend?
Yeah. So one very small book, many years, I mean, that was a few decades ago, that I read was Jonathan Livingston Seagull,
Yeah,
and that whole pursuit of excellence, which was in some sense a key learning from that book, really
yeah.
stuck with me.
Wow, that's a great recommendation. Uh, what does your typical day look like? Are you a morning person? Are you someone who spends late at night working on problems?
Yeah. So it's a bit of both.
Mhm.
So yes, I do start the day in the morning to try and I do prefer coming into work um, every working day, and so to beat the traffic, I try to start a bit early, and then usually I kind of go back home uh, in some sense late afternoon or early evening, and then try to get some break, some downtime. Uh, Kind of get my usual walk or go to the gym, and so after that break, just have my dinner, and then often then there are often we have, being in a global company, you have often meetings with your colleagues who are based in other time zones, and but people are very nice, and you are still able to kind of maintain whatever your own bounds in terms of the times, right, beyond which you do not need to attend those meetings, and kind of be ready for the next day.
Mhm. And over the last few years, uh, what has been one thing which has impacted you or most as a professional, so has made you grow as a professional? Any particular practice, anything which you do which kind of has helped you a lot over the last few years?
Yeah, so I would say the main thing
Mhm.
uh, which has really helped me is the amazingly smart people around me.
Mhm.
So I always, when I'm building up teams, I always strive to build up teams of people who are much smarter than me. And it's been, again, wonderful learning from them, because a lot of, again, what I know is things that I have learned from my wonderful colleagues. Yes, I'm not the expert in most of those things. I mean, my colleagues are bigger experts, but where I can add value is by challenging them, right, to set sometimes more ambitious goals, or helping connect the dots. Uh, uh, but it's been extremely wonderful, just working with an amazingly talented set of people that I've had the privilege of working with over the years.
Great. Thanks. Thanks a lot, Manish, for sharing those perspective, your journey, and then how you are thinking about the future. And I look forward to seeing you at the Data Hack Summit.
Thank you. Thank you, Gunnar.